Hello. Today we're going to be talking about solving some compound inequalities involving the word and. So right now we're on page 82. It's not the one that I wanted. Page 82. So if you're not on page 82, go ahead and find your textbook. You're turning to page 82 right now. And let's talk about some compound inequalities. So starting on this first sentence, combining two or more simple inequalities forms a compound inequality. The graph of a compound inequality involving and is the intersection or the overlapping region of the simple inequality graphs. So if we take a look at our table down below, we have examples of when we use compound inequalities given the word and. So and is our big word here. So let's take a look. In words, we have all real numbers greater than 2 and less than 6. Okay. Our keyword here is and. So we want all numbers bigger than 2 and smaller than 6. That's our equation exactly how we have it here. So if I were to graph this, well, I would have all of my numbers bigger than 2. That's an open circle. Okay, that does not include 2. It's everything bigger than 2. So we can even write an arrow going to the right. And we want all numbers strictly less or fewer than 6. So then my arrow is going to the left. Okay. But again, that word and means that I'm only graphing my overlap. And this is where my graphs overlap, is between those values of 2 and 6. Now, the only thing that's different for our second row here are these words, or equal to. Our symbol also changes. We took a look at these symbols last class. So we have a greater than or equal to sign and a less than or equal to sign. Now, the only thing that's different with our graphs is whenever we see that equal sign, now we're including that value. So I'm including 2 and I'm including 6. So I'm going to shade in those two values because now they belong in my graph. So let's take a look at this example 1. It says solve each compound inequality and graph the solutions. We have 4 is less than or equal to x plus 2, and x plus 2 is less than or equal to 8. Sometimes we will see our compound inequalities looking like this. This is just a combination of two simple inequalities. If it makes you feel more comfortable, you can write the compound inequality using the word and. They did that for us. So they broke our compound inequality up into two parts, the left and the middle, and then the middle and the right. Two different inequalities. And once you have those inequalities, well, it's sort of like what we did last class. We want to get x all by itself. So let's take a look at this first one. If I want to get x all by itself, well, I have to undo a positive 2. And how do I undo a plus 2? I subtract 2 from both sides here. If I subtract 2 from both sides, my 2's cancel out. 4 minus 2 gives us a 2. I bring down my sign, and I bring down my x. So I first have my 2 is less than or equal to x. At the same time, I can solve my other inequality. I'm going to subtract 2 both sides. My 2's cancel out. I'm left with an x. 8 minus 2 gives us a 6. We bring down our sign. So we have two different inequalities. First, we graph our first one. I want all numbers bigger than or equal to 2. All numbers bigger than or equal to 2. So I find my 2. This is including 2, so I have a closed circle. I want all numbers bigger than that. I'm going to draw my arrow to the right. If I want my graph to be x is less than or equal to 6, I'm going to find my 6. That is all numbers smaller than 6. So I'm drawing my arrow to the left. Okay. Now if I want the intersection of these two inequalities and their graphs, well, we're going to see where they overlap. And they overlap at this dotted line. They overlap between the values of 2 and 6, and that's exactly what I shaded in my graph. So let's take a look at one example here. Example 1. We have this inequality. -5 is less than or equal to 2x plus 3, which is less than or equal. Nope, strictly less than. That was my fault. Strictly less than 9. So be very careful of your signs here. If you do not want to separate them into two inequalities, well, we're going to do all of my steps at the same time. Okay? So whatever I do to one piece of my inequality, I have to do to my other pieces as well. So I have my left piece, my middle piece, and my right piece. So let's take a look. Here's my x in the middle, and I want to get it all by itself. I want to undo this positive 3, so I'm going to subtract 3 from each part of the inequality. So I'm going to subtract 3, subtract 3, subtract 3. From my first piece, my middle piece, and my last piece. Now let's subtract. -5, take away 3 more, gives me a -8. My 3's cancel out in the middle. And I'm left with 9. Take away 3 on the right-hand side. I'm left with a 6. I'm still not done. I want to get x all by itself, but what's attached to it? It says multiplication of 2. We undo multiplication by dividing. What are we going to divide by? 2. All sides. Eight divided by 2 gives us a -4. 2 divided by 2 just leaves us with x. And 6 divided by 2 gives us a 3. And now I get to graph. We're going to graph -4 is less than or equal to x. Sometimes makes it easier to read it this way. X is greater than or equal to -4. Okay, so let's find my -4. Is my -4 included? It has that equal sign, so I'm going to shade it in. Okay. And I want all my values bigger than -4. Bigger is to the right. I'm going to draw that arrow. I'm going to graph x is less than 3, so I'm going to find 3. Okay. Open circle, close circle. Open circle. Okay. We're going to shade everything to the right. And then all we have to do is put these together. Close circle on -4. Open circle on 3. And then we're going to shade everything in between. Okay. Now I want you guys to try the your turn problems. Okay. 3 and 4. And when you're done, come show it to me.